This is SpaceTime Series 20 for episode 136, full broadcast on the 29th of November 2021. Coming up on SpaceTime, the near-Earth asteroid which may actually be a lost fragment of the Moon, the fastest spinning white dwarf ever seen, and NASA's DART mission blasts off on a journey to slam into an asteroid. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims that a near-Earth asteroid may actually be a lost fragment of the Moon. The 150-metre wide space rock called Kamo is a quasi-satellite, orbiting around the Sun with the Earth and often getting to within 15 million kilometres of Earth. A report in the journal Nature Communications claims its spectra closely matches lunar rocks brought back by NASA's Apollo 14 mission, and that suggests its origin may well be the Moon. Little is known about these quasi-satellites orbiting with the Earth around the Sun because they're very faint and difficult to observe. Kamo was discovered by the Pan-STARRS telescope in Hawaii in 2016. And as for that name, well, it's found in an Hawaiian creation chant, and it alludes to an offspring who travels on its own. Due to its orbit, Kamo can only be observed from Earth for a few weeks every April. And its relatively small size means it can only really be studied using really big telescopes. So in order to achieve that goal, astronomers use the giant twin 8.4-metre telescopes of the Twin Binocular Observatory, located on Mount Graham in southern Arizona. The study's lead author, Ben Sharkey from the University of Arizona, says despite examining every known near-Earth asteroid spectra, nothing matched except the spectra of lunar rocks brought back by Apollo. The problem is the authors haven't been able to come up with a good hypothesis to explain exactly how this massive chunk of the Moon broke loose. Its orbit around the Sun is very similar to Earth's, but with a slight tilt, certainly not typical of any near-Earth asteroids. Computer simulations suggest Kamo probably moved into its current orbit about 500 years ago and should remain in this orbit for at least another 300 years. Plenty of time to ponder its mysteries. This is SpaceTime. Still to come, the fastest spinning white dwarf star ever seen, and we've just experienced the longest partial lunar eclipse since 1440. All that and more coming up on SpaceTime. Astronomers have discovered the fastest white dwarf star ever seen. The white dwarf, named Lamost J024048.51 plus 195226.9, completes a full rotation on its axis every 25 seconds. Now, by comparison, our Sun takes some 29 Earth days to complete one rotation. White dwarfs are the collapsed cores of Sun-like stars. Stars shine by fusing hydrogen into helium in their core. When they run out of core hydrogen for fusion, they contract. That causes an increase in core temperature and pressure until they begin fusing core helium into carbon and oxygen. At the same time, a shell of hydrogen begins burning on the outside of the core. And that causes the star's outer gaseous envelope to expand. And as it's now much further away from the contracted core, it cools down, turning the star into a red giant. Eventually the star runs out of core helium to fuse, and as it's not massive enough to fuse heavier elements, the star dies. Its bloated outer envelope floats away as a spectacular cloud called a planetary nebula, and its white-hot stellar core is exposed as a white dwarf. Astronomers think around 97% of all stars will eventually become white dwarfs. A report in the Journal of the Monthly Notices the Royal Astronomical Society letters suggests that this particular white dwarf is pulling gaseous plasma from a nearby companion star and then flinging it into space at around 3,000 kilometres per second. Now, this star is about the size of the Earth, but is thought to be at least 200,000 times more massive. That makes it extremely dense, so there's a lot of gravity being packed away there. Now, a report in the journal The Monthly Notices the Royal Astronomical Society letters suggests that the white dwarf is pulling gaseous plasma from a nearby companion star and then flinging this gas into space at some 3,000 kilometres per second. Now, this plasma would have been falling onto the white dwarf's equatorial region at high speed, and that provided the energy to give the star its dizzying spin. At some point during its evolutionary history, the white dwarf developed a strong magnetic field. And this magnetic field acts as a protective barrier, causing most of the infalling plasma to now be propelled away from the white dwarf at high speed. The remainder still flows towards the white dwarf's magnetic poles. The plasma then gathers in bright spots on the surface of the white dwarf, and as these rotate in and out of view, they cause pulsations in the light coming from the white dwarf, which astronomers here on Earth can observe and use to measure the star's rotational speed. And what this has told scientists is that the rotational speed of this white dwarf is so fast, it means the white dwarf must be really big in order to have enough mass to stay together and not be torn apart by such a high spin rate. The white dwarf is one of only 2 known stars with this type of system in operation, providing astronomers with a cosmic laboratory to study these sort of effects. This is SpaceTime. Still to come, the longest partial lunar eclipse since 1440, and NASA's DART mission blasts off on a journey to slam into an asteroid. All that and more still to come on SpaceTime. Skywatchers over much of the world have enjoyed the longest partial lunar eclipse in nearly 600 years, with the moon bathed in a brilliant scarlet. The celestial sky shows saw the lunar disk almost completely cast in shadow as it slowly moved behind the Earth, with the refracted sunlight passing through the Earth's atmosphere and reddening 99% of the lunar face. The spectacle was visible across all of North America, as well as parts of South America, parts of Australia and the Pacific, and northeastern Asia. The dramatic reddening is caused by Rayleigh scattering, where the shorter blue light wavelengths of the Sun are dispersed by particles in Earth's atmosphere, allowing the longer red wavelengths to pass through and dominate. It's the same effect that makes sunsets look red. And in this case, it was the moon showing all the sunsets and sunrises on Earth at the same time. And the more dust or clouds in the Earth's atmosphere during the eclipse, the redder the moon appears. From the moment the eclipse began, when the moon entered Earth's shadow, to when it ended, took more than 3 hours and 28 minutes. And that's the longest partial eclipse since 1440, around the time Johannes Gutenberg invented the printing press. And to say it's a rare event is an understatement. In fact, the next lunar eclipse this long won't happen again until 2669. But if you can't wait that long, there'll be a somewhat shorter total lunar eclipse on November the 8th next year. This is SpaceTime. Still to come, NASA's DART mission successfully blasts off on a journey to slam into an asteroid, and later in the science report, a new look at what caused the world's worst mass extinction event. All that and more still to come on SpaceTime. NASA has successfully launched a new mission which could eventually save planet Earth from an asteroid impact. The Double Asteroid Redirection Test, or DART spacecraft, blasted off aboard a Falcon 9 rocket from the Vandenberg Air Force Base in California.
Falcon 9, go for launch.
And there's that final go for launch with all systems go for T0. Let's listen into the terminal count. Falcon 9, transport NASA's DART spacecraft into orbit.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Falcon 9 with the DART mission on the way for humanity's first ever planetary defense test mission.
Vehicles pitching downrange. Stage 1 chamber pressure is nominal.
T plus 33 seconds. SpaceX launch engineers seeing a nominal conditions on Falcon 9 as we begin the trip to space carrying the DART spacecraft. M1D engines about to begin throttling down.
Power and telemetry nominal.
We're throttled down. Avionics calls out good power on the vehicle.
Vehicles supersonic. Max Q.
We've gone supersonic. We're through the period of maximum dynamic pressure. And the Merlin 1D engines have throttled back up to full power. We're out of the throttle bucket. From here on, even though the velocity is rapidly increasing, the atmospheric density is decreasing, and so the loads are decreasing now on the Falcon 9. Everything continues to look good with the stage 1 trajectory.
Invec chill has started.
Lead valve is open on the second stage engine. That's beginning the final chill prior to second stage engine ignition. 2 minutes into flight, all continues to go well. In 30 seconds, we'll have 3 significant events coming up in quick succession. We'll get MECO, main engine cutoff, where we shut down the 9 Merlin engines. The stages will separate, and we'll get ignition of the MVAC-D second stage engine to power DART and the second stage into their parking orbit. We've throttled down to hold at 4 Gs, getting ready for MECO.
MECO.
Stage separation confirmed.
Invec ignition.
We've got successful stage separation. Second stage engine ignition now at full power on the Merlin engine. Next event coming up is going to be payload fairing jettison. The titanium grid fins on the first stage beginning to deploy as we get ready to bring the first stage back down to the drone ship, Of Course I Still Love You, in the Pacific Ocean. And we've got deployment of the payload fairing and now the DART spacecraft exposed to the vacuum of outer space. Now we will be attempting to retrieve these new fairing halves with the help of our recovery vessel, NRC Quest.
Stage 2 on nominal trajectory.
Everything going well with Falcon 9 and DART.
We are currently in the first of 2 planned MVAC burns for spacecraft deployment today. At T plus 6 minutes and 40 seconds, the first stage entry burn, and that entry burn will last about 30 seconds. Now for the entry burn, we do relight the center E9 engine, and then partway through we relight the E1 and E5 engines, so that we have 3 total M1D engines helping to slow the vehicle down as it passes back into the Earth's atmosphere. And everything is still looking nominal for stage 2. At T plus 5 minutes into this mission, we're just under 2 minutes away from the entry burn on the first stage, as second stage is continuing on its journey. Again, this is the first of 2 planned MVAC burns for this mission. Now, the Falcon 9 booster supporting today's mission will perform this entry burn for the 3rd time, because it's previously supported a Starlink mission earlier this year, and the
Stage 2 on nominal trajectory.
Just a call out that stage 2 is looking nominal, which is great news. The first stage booster, again, supported a Starlink mission earlier this year and the Sentinel-6A mission in November of 2020. Now, both fairing halves for this mission are brand new and will be recovered for the first time on a recovery vessel, NRC Quest. As a reminder, the Merlin engines on the first stage are optimized for sea level, and these do achieve 190,000 pounds of thrust during ascent and descent.
Stage 1 FTS is saved.
And we heard the call out as well as visual confirmation that the entry burn has begun on the first stage. Again, this is about a 30-second burn and just helps to slow the vehicle down as it's re-entering the denser part of the Earth's atmosphere.
Stage 1, entry burn shut down.
The entry burn is complete.
Stage 2 FTS is saved.
Stage 2 continues on a nominal trajectory. Now coming up in
Terminal guidance.
just a little over a minute will be SECO 1. That is second stage engine cutoff 1. Again, there's 2 burns for the MVAC engine on the second stage, so we are in the first burn.
Expected loss of signal code.
So we should see this engine shut off here shortly. And about 20 seconds later, we'll see or hear the landing burn call out on first stage begin.
Invec shut down.
And we just
Nominal orbit insertion.
That's what we were waiting for.
Stage 1, landing burn startup.
So we got SECO 1 on second stage. We got a confirmation of good orbit, and the landing burn has begun on first stage. And now we have a live view of first stage making its way to, Of Course I Still Love You.
Stage 1, landing leg deploy.
And we will wait for that confirmation of that first stage landing. But you have just witnessed Falcon 9's 26th flight for this year. And we will confirm once we have that confirmation for that first stage landing. So now at this time, our mission isn't over just yet. The second stage is now embarking on its first coast phase. Coasting in this orbit will last about 20 minutes, and we will light that MVAC engine for a second time shortly after T plus 28 minutes and 38 seconds.
Its 10-month, 11 million kilometre journey will intercept the 780 kilometre wide asteroid Didymos and its tiny 160 metre wide moon Didymoon, which has apparently been renamed Dimorphos in order to remove any confusion between the pair. In September next year, DART will slam into the tiny moon at some 6.6 kilometres per second. The kinetic impact should create a 20-metre deep crater in the moon's surface. And if scientists are right, cause a tiny deflection in its orbit around Didymos, shortening it by several seconds and sufficient to be measured with Earth-based telescopes and radar. The collision will not only tell scientists about the effectiveness of deflecting a potential Earth-impacting asteroid or comet, but also about the composition and structure of some of the asteroids in near-Earth orbit. For example, are they solid rock or simply gravitationally bound rubble piles? And the DART mission doesn't end there. In November 2024, the European Space Agency will launch Hera, which will fly to the Didymos system to undertake a detailed close-up analysis of the effects of the collision. Once in orbit around Didymos in 2026, Hera will deploy 2 small CubeSats, which will carry out additional research, including close-up surface observations, radar soundings, and eventually a landing on the moon's surface. Astronomers have so far identified more than 27,440 known near-Earth objects, including 117 comets and more than 27,323 asteroids. A near-Earth object, or NEO, is any small solar system body whose orbit brings it close to the Earth. This list includes some 2,224 NEOs that are also classified as potentially hazardous asteroids. And these are asteroids greater than 140 metres in size, whose orbits cross Earth's orbit around the Sun, and therefore are potential impactors. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. Australia has banned travel from 9 South African countries following the discovery of the new B11529 Omicron variant of the COVID-19 coronavirus. Scientists are racing to find out more about the new strain, which first turned up in Botswana in early November. Since then, it's quickly spread through South Africa and from there through travellers to Hong Kong and Belgium. The World Health Organization has classified the new strain a variant of concern, as it includes more than 30 protein spike mutations, some of which are quite concerning. Preliminary evidence suggests it has an increased risk of infection compared to other variants such as Delta. Pfizer and AstraZeneca say they can adapt their vaccines to deal with the new variant, while Moderna says it's already testing a high-dose booster designed to combat the new strain. A new study has better quantified how well different measures work to reduce the spread of the COVID-19 coronavirus. The research reported in the British Medical Journal suggests that wearing a mask reduces the spread of the virus by as much as 53%, and regular hand washing is associated with a similar reduction in spread, while physical distancing will reduce the spread of the coronavirus by 25%. The authors say more studies are needed to be clear on the impact of other measures like isolation, quarantine, and school closures. More than 5.2 million people have now been killed by the COVID-19 coronavirus since it first spread out of Wuhan, China. However, the World Health Organization says the true death toll is likely to be double that amount, with more than 250 million confirmed cases. A new study suggests a series of massive volcanic eruptions, rather than just one specific event, may have triggered one of the planet's greatest mass extinction events. The end Permian mass extinction event, some 250 million years ago, wiped out between 80 and 90% of all life on Earth. For years, scientists have blamed the catastrophe on the Siberian traps, a massive split in Earth's crust which continuously spewed oceans of magma onto the surface for some 2 million years, spanning the Permian-Triassic boundary. The evidence for the massive rupture is a flood basalt lava plain covering some 7 million square kilometres of Siberian tundra and containing some 4 million cubic kilometres of basalt rock. But now a report in the journal Science Advances suggests a second volcanic eruption, this one in southern China, may have further contributed to the apocalyptic event. The findings, based on mineral and sediment analysis, suggest that these additional eruptions may have further contributed to a volcanic winter which devastated life on the planet, almost wiping the slate clean. Australia's Bureau of Meteorology says we have entered a La Nina weather pattern. The weak La Nina will be here for a couple of months, causing cooler, wetter conditions across much of eastern and central Australia. The El Nino and La Nina Southern Oscillation pattern, known as ENSO, is the primary meteorological driver influencing Australia's weather and climate on a year-to-year basis. It's a naturally occurring shift in ocean temperatures and weather patterns along the equatorial Pacific, causing a change in atmospheric circulation. These cycles loosely operate over timescales ranging from 1 to 8 years. The name El Nino, meaning little boy or Christ child in Spanish, comes from Peruvian fishers who noticed reduced catches of anchovies during periods of unusually warm water in the Pacific in the 1600s. El Nino causes extended periods of warming sea surface temperatures in the central and eastern tropical Pacific, with high surface pressures in the tropical western Pacific. For Australia, El Niños tend to result in periods of warmer temperatures, reduced rainfall and increased drought, and higher fire dangers, while the Americas tend to experience increased rainfall, flooding, and more storm activity. El Niño's counterpart, La Niña, or little girl, is associated with lower sea surface pressure and extended periods of cooling sea surface temperatures in the central and eastern tropical Pacific. La Nina results in increased rainfall and flooding across eastern and central Australia, with more storm and tropical cyclone activity. During a La Nina period, US winter temperatures are warmer than normal in the south and cooler than normal in the north. Well, it's outrageous. Australia has failed to score even a mention in a new list of the most haunted places on Earth. Top of the list was the Château de Brézac in France, which is said to be haunted by the illegitimate daughter of King Charles VII, who was murdered by her husband after he discovered her having an affair. That's apparently followed by a cemetery in Buenos Aires, which is said to be haunted by the ghost of a gravedigger who committed suicide. And the Banff Springs Hotel in Canada came in third. It's apparently haunted by the ghost of Sam the bellboy. Tim Mendham from Australian Skeptic says even New Zealand got a mention, but it seems Australia just isn't scary enough.
Yeah, no, this is really disappointing. I feel left out here. I mean, it's a list of most haunted places, and they're different places from different countries, etc. And all around the world, even New Zealand gets one, but Australia doesn't get any. I mean, apparently we're not very scary. We don't have any haunted places, which is disappointing. I mean, yeah, the list is sort of, it's pretty broad brush if you want to sort of look at the most haunted places in the world, not the most haunted places in my neighbourhood or something. But some of these are your perennial, like the Stanley Hotel in America, which is inspired Stephen King to write The Shining, which is not the hotel in the Kubrick film, The Shining, but it is in the remake that Stanley King made based on The Shining. So it's got a bit of a checkered history, but that's supposed to have all sorts of ghoulies and things. Another one is the really weird, the Aokigahara, I hope I pronounced that correct, Aokigahara Forest in Japan, which is also known as the Suicide Forest, where people go to commit suicide. And it's a bit of a, people are very mixed about the purposes and whether this place should even exist. But people do go there, and of course, naturally, with all these suicides, there are spirits hanging around. Other places, Tower of London, that's pretty straightforward. There's the Castle of Good Hope, which doesn't sound, very encouraging. In South Africa, there's the Forbidden City in Beijing, and there's Alcatraz, the island in San Francisco, and the one in New Zealand is called Larnac Castle, which I don't know.
They have castles in New Zealand? That's amazing.
There's not many castles. I think there's more a stately home, right? And someone obviously built a stately home that and it's built by a fellow named William Larnock and his family. The ballroom is supposed to be haunted by his favourite daughter. So, she died of typhoid, etc. So, that's the one in New Zealand, which I don't know, which perhaps needs a good bit of publicity. Perhaps the
Edinburgh Castle didn't make the list. That's amazing.
Yeah. Perhaps the New Zealand Tourist Board or whatever they are should actually get onto that and promote that more. But I'm sure there's some scary places in Australia. I mean, where I live is scary.
You've got that road, haven't you?
There's the road, which is in Sydney, which is a road through the bush between suburbs, which is supposed to be figures keep appearing.
The Wakehurst Parkway we're talking about, folks.
Yeah, the Wakehurst Parkway in Sydney. And that's supposed to be haunted, and people suddenly appear in your back seat and then disappear when you're driving through it, or appear by the side of the road or whatever.
Which can be most uncomfortable, appearing in your back seat.
I think it would be, actually, someone just suddenly appearing in your back seat, sitting there saying, just let me off here, thanks. But, no, that one doesn't rate a mention. I thought, nothing in Australia rates a mention. Apparently we're a very boring bunch.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.